There is a place that does not appear on any satellite image, not because it is hidden by trees or buried under a mountain range, but because whoever built it made absolutely certain that no lens, no sensor, no orbital pass would ever catch a single detail worth reporting. The ground above it looks ordinary. A stretch of flat terrain, maybe a dirt road cutting through dry earth, maybe a cluster of unremarkable buildings that could belong to any industrial zone in any corner of the world. Nothing moves on the surface, nothing hums, nothing glows, and yet, if you pressed your ear to the ground at exactly the right spot, you might feel something. Not a sound exactly, more like a pulse, a deep, rhythmic vibration traveling up through layers of compacted soil and reinforced concrete, rising through the soles of your feet and settling somewhere behind your sternum. Something is alive down there, something that never stops. The elevator that descends into this facility has no floor numbers. It has no buttons at all, in fact. Just a single panel that reads your biometrics in under a second and decides, without explanation, whether you are allowed to go down. The descent takes longer than you expect. The walls of the shaft are bare metal, faintly illuminated by strips of cold white light that pulse almost imperceptibly as the car drops. You count the seconds, 15, 20, 30, and then the doors open, and the scale of what lies in front of you takes a moment to fully register. The ceiling is 40 meters above the floor, maybe more. It is held up by columns of reinforced steel so thick that 3 people could not wrap their arms around a single one, spaced at perfect intervals across a floor that stretches so far in every direction that the far walls are barely visible through the haze of industrial air. The light here is blue-white and even, cast by arrays of high-output panels mounted to the ceiling in geometric grids, eliminating shadows almost entirely. Almost. In the corners, in the spaces between machines, darkness pools in thin strips, the only reminder that this place was carved out of the earth, that it exists below everything, that no natural light has ever touched these walls. And in the center of all of it, arranged in rows so precise they look like they were measured to the millimeter, the machines are already working. They have been working for a long time. You can tell by the way they move, not with the hesitation of systems running a new cycle, but with the fluid, automatic confidence of processes so deeply embedded in their programming that each motion has been performed thousands of times before. These are not the industrial robots of the previous century. They are not the welding arms you might see in a conventional automotive plant, fixed to a single point, repeating a single task. These machines stand upright. They have torsos, shoulders, articulated limbs that bend and rotate and reach with a range of motion that, in dim light or in your peripheral vision, could briefly trick your brain into seeing something almost human. Almost. The proportions are not quite right. The limbs are slightly too long. The movements are slightly too smooth, too continuous, too perfectly economical. Never a wasted motion, never a pause that was not calculated, never a gesture that did not serve a specific mechanical purpose. They stand between 2 and 3 meters tall, depending on the configuration, and they move through the factory floor with an unhurried, purposeful gait that makes the entire space feel like it is breathing. There are hundreds of them, maybe more. The exact number is difficult to determine because at any given moment, some are stationary and working, others are in transit between stations, and others are clustered around a single component in groups of 4 or 6 or 10. Their movements coordinated so precisely that they look less like individual machines and more like a single distributed organism executing a shared intention. The first station you pass is the materials bay. This is where the raw structure of the aircraft begins, not as a recognizable shape, but as a collection of precisely cut composite panels, titanium framing sections, and high-density polymer components that have been delivered on automated carts from the storage vault at the far eastern end of the facility. Each piece arrives with a microscopic identification tag embedded in its surface, invisible to the eye but immediately readable by the sensor arrays built into the robot's fingertips. A humanoid unit reaches into the cart, lifts a composite panel that weighs over 80 kilograms as if it were a sheet of paper, holds it at arm's length, and rotates it slowly, running a full surface scan in under 3 seconds. The scan data is transmitted instantly to the central processing system, a distributed AI architecture that monitors every station simultaneously, tracking material tolerances, identifying microscopic variances, and adjusting assembly parameters in real time without any human input. If the panel passes, it moves forward. If it doesn't, the robot sets it aside on a rejection rack with the same unhurried precision it used to pick it up. There is no frustration in the gesture. There is no urgency. There is only process. The camouflage work begins earlier than you might expect. Most people assume that a paint job, even a sophisticated military-grade one, is something that happens at the end of an assembly process, a cosmetic finish applied to a completed structure. Here, that assumption collapses almost immediately. The camouflage on these aircraft is not paint. It is not a coating applied to an exterior surface. It is built into the material itself, integrated at the panel level before a single structural component is joined to another, because the patterns that need to emerge on the finished aircraft are not simple. They are precise, mathematically derived, optimized for specific spectral frequencies and observational angles, and they require a level of consistency across every panel that no spray system, no matter how advanced, could reliably deliver after the fact. The panels that arrive at the coding station are already the right shape. They have already been cut, scanned, and validated. What happens here is the layering of a multispectrum treatment that begins with a base absorptive substrate, a material so dark it seems to pull light into itself, and builds outward through successive applications of pigmented polymer layers, each one cured under precisely controlled ultraviolet exposure before the next is added. The robots performing this work are smaller than the structural assembly units. Their fingers are finer, their movements more delicate, their sensor arrays more densely packed. They apply each layer with a tool that resembles nothing so much as a wide, flat brush, but which is in fact a precision applicator delivering material at a controlled rate of microns per pass, guided by optical feedback systems that measure the thickness and uniformity of each layer as it is deposited. The patterns that emerge are extraordinary to look at. They are not the simple geometric shapes of older camouflage systems, not the broad blotches of green and brown designed for forest concealment, not the angular high-contrast blocks of urban patterns. These are something else entirely. They shift, not dramatically, not visibly in real time, but as you move around a completed panel, as your angle of observation changes by even a few degrees, the pattern seems to breathe, to reconfigure subtly, to present a slightly different arrangement of tones and shapes. It is an optical effect built into the layering structure of the material itself, a consequence of the way different pigment layers interact at different viewing angles, and it is deeply unsettling in a way that takes a moment to articulate. The panel does not want to be looked at. That is the sensation. The surface resists your focus. Your eye keeps sliding off it, seeking a fixed reference point, and finding none, because the pattern is specifically designed to defeat exactly that cognitive process, the one your brain uses to recognize an object as a discrete, bounded thing. When an aircraft skinned in this material moves through the air at altitude, at speed, against a background of shifting light and cloud, it becomes extraordinarily difficult to hold in your visual field. Not invisible, not a ghost, just difficult, resistant, a thing your eye keeps losing. Beyond the coding station, the structural assembly begins in earnest, and this is where the scale of the humanoid robot workforce makes its full impact felt. Aircraft assembly, at the level of sophistication demanded by what is being built here, is not a linear process. It is not a matter of attaching piece A to piece B and then adding piece C. It is a three-dimensional coordination challenge involving dozens of components that must be positioned simultaneously, held in precise alignment while fasteners are applied, and monitored continuously for stress and deformation during the joining process. In a conventional facility, this would require enormous jigs, scaffolding structures that hold components in position while human workers move around and through them. Here, the robots are the jig. Groups of 6 or 8 humanoid units surround a major structural component, a fuselage section, a wing root fitting, a forward bulkhead, and lifted into position together, their movements synchronized to a degree that the combined assembly behaves like a single hydraulic system. They do not communicate verbally. They do not communicate visibly at all. The coordination happens through the central AI, which is feeding positional corrections to each unit multiple times per second, maintaining alignment tolerances measured in fractions of a millimeter across distances of several meters. Watching this process is mesmerizing in a specific way. There is something about the silence of it. The fact that all of this coordination, all of this complexity, all of this precision is happening without a single sound, beyond the soft mechanical breath of servos and the occasional quiet percussion of a fastener being seated, that creates a sensation almost like watching something that should not be possible. The human brain has not evolved to process the sight of large, vaguely humanoid forms moving in perfect unison without any of the social signals, the glances, the gestures, the spoken words that normally accompany coordinated physical effort between bodies. It reads as wrong, somehow. Not threatening, not alarming, just fundamentally strange in a way that keeps pulling your attention back. The wing assembly station occupies a section of the floor roughly the size of a sports arena. This is not an exaggeration. The wings of the aircraft being built here are long, not the wide delta platforms of older supersonic designs, but a swept, tapered geometry that suggests something optimized for a very specific flight envelope, something that needs to be extremely efficient at altitude and speed, while also maintaining a minimal radar cross-section. The leading edges are curved in ways that are almost organic, and when a completed wing section is lifted by a team of robots and carried across the floor toward the main fuselage assembly point, the movement of it through the air, the way it cuts the light, the way the camouflage panels shift across its surface as the angle changes, is genuinely striking. There is a moment, watching this, when the wing catches the blue-white ceiling light at just the right angle and the surface seems to almost disappear, to become a flat plane of nothing, an absence in the air rather than a presence. And then it rotates a few degrees, and it is simply a wing again, solid and immense and real. The fastening systems used here are unlike anything in commercial aviation manufacturing. There are no visible bolt heads on the exterior surfaces, no rivets. The joining methods are embedded, structural adhesive systems activated by precise heat application, combined with internal mechanical fasteners that are inserted through access ports and then sealed. The robots performing this work have interchangeable end effectors, the tools that attach to the ends of their arms, that they swap with fluid efficiency at a tool station between tasks, each change taking under 4 seconds. Some of these tools are familiar enough in concept: torque drivers, adhesive applicators, heat lances. Others are less recognizable, devices that emit a low sound, almost below hearing, that seem to have some effect on the material being joined. Though what exactly that effect is and why it produces better structural bonds than conventional methods alone is not immediately apparent. The noise of this place is worth dwelling on. It is not the cacophony you might associate with heavy manufacturing. It is layered, complex, and deeply ambient, the kind of soundscape that ASMR content creators spend years trying to artificially construct, and that here simply exists, a natural byproduct of precision machinery operating at scale in an enclosed subterranean space. The base layer is a deep, subsonic rumble from the facility's climate control systems, which must move an extraordinary volume of air to maintain the temperature and particulate levels required by the manufacturing processes. Over this sits the mid-range mechanical presence of hundreds of robot units in constant motion. Not loud exactly, but pervasive, a steady background of servo hum and joint movement that never fully drops below the threshold of hearing. And above this, occasional sharp punctuations. The clean click of a fastener seating correctly. The brief high whine of a calibration scan being performed. The soft pneumatic exhale of a clamping system releasing. It sounds, in a strange way, like music. Like a very slow, very large, very patient piece of music being performed by an orchestra that has been rehearsing for so long that every player knows every part of every other player's score. The avionics integration bay is sealed behind a partition wall with its own access control system. Even within this facility, there are layers of restriction. The robots that work here are different again, lighter, more precise, equipped with sensing systems that make them almost surgical in their movements. The internal architecture of the aircraft is, by this point, taking recognizable shape. You can see the main structural frame of the fuselage, the wing attachment points, the engine nacelle mountings. But the interior is still largely open, a skeletal framework waiting to receive the systems that will make it functional. Wiring harnesses are installed first. These are pre-assembled bundles of data and power cabling that have been fabricated in a separate area and delivered on carts, each bundle labeled and positioned in a specific sequence. A robot with particularly fine-fingered manipulators reaches into the airframe interior and begins routing a harness through a series of clips and brackets, threading it around structural members, securing it at intervals with small fasteners. The work requires a combination of reach, dexterity, and spatial awareness that would challenge a skilled human technician. The access is tight, the routing path has many constraints, and the harness must arrive at its termination points with enough slack to accommodate the thermal expansion and vibration that will occur in operation without enough excess to create chafing risks. The robot performs this work without hesitation and without error. The avionics boxes themselves, the processors, the sensor fusion units, the communication systems, are installed after the wiring is in place. Each unit is handled with a care that borders on reverence, lifted from its protective packaging, scanned, positioned in its mounting tray, and fastened down with a torque that is verified automatically before the robot moves to the next component. Connections are made and tested immediately, the AI monitoring signal integrity across each new junction as it is established, flagging any anomaly for re-inspection before the assembly moves forward. There are no anomalies. There have not been any in a long time. The propulsion systems arrive in their own sealed containers, moved by dedicated heavy-lift robot units that are built differently from the assembly workforce. Lower, wider, more massive, without the humanoid upper body that characterizes the general assembly robots. These are purpose-built movers, and they navigate the facility floor with the calm inevitability of something that has right-of-way everywhere it goes. Other robots shifting out of their path without any visible coordination, simply because the AI has already routed all other units to avoid the corridor the mover will use before the mover has begun moving. The engines, and calling them engines feels reductive, feels like using a word developed for something far simpler to describe something that represents a significant departure from conventional propulsion architecture, are lowered into their nacelles by the heavy lift units working in precise coordination with a team of assembly robots that guide the installation from inside the airframe. The process is slow, deliberate, the kind of slow that communicates not inefficiency, but extreme care. The recognition that what is being positioned must be positioned correctly, because correcting an error at this stage of integration would require undoing hours of work. The fit, when it comes, is exact. You feel it before you see it, somehow. A slight change in the acoustic environment of the bay, as if the structure has found a configuration it was always meant to occupy. The assembly of the aircraft continues through what, if you were tracking time by conventional measures, would be described as night and day, though of course neither concept has any meaning in a space that receives no natural light and whose operational schedule is defined purely by process requirements rather than human biology. The robots do not require breaks. They do not require meals or rest or the small interruptions that human workers need to sustain themselves through a long shift. They operate continuously, and the only pauses in their activity are the pauses demanded by process. Waiting for an adhesive to cure, waiting for a scan to complete, waiting for a component to arrive from another station. During these pauses, the waiting robots are not idle. They run self-diagnostics, they recalibrate their sensor systems, they perform minor maintenance tasks on themselves and on the workstations around them. They are never simply standing still, because standing still is not a state that exists in their operational programming. The surface finishing stage arrives gradually, as more and more of the exterior panels are fitted and joined and blended into the continuous skin of the aircraft. This is where the camouflage treatment that began at the panel level becomes something larger, where individual panels that were processed separately must, when joined together, present a unified, continuous surface without visible seams or boundaries in the pattern. Achieving this is one of the more technically demanding aspects of the entire assembly process, because the pattern is not random. It is mathematically structured, and the mathematical structure must be maintained across panel boundaries with the same precision that tolerances are maintained in structural joints. The robots assigned to this task are equipped with optical systems that can read the pattern on adjacent panels and compute, in real time, the precise application required to blend the boundary invisibly. They work in pairs, one robot maintaining position on either side of a seam, their movements mirrored with a symmetry that would be beautiful if you allowed yourself to think of the word in this context. And perhaps you should. Perhaps beauty is not an inappropriate response to precision at this scale, to the sight of machines that exist entirely outside the framework of human aesthetics, producing nonetheless results that are genuinely extraordinary to look at. The aircraft is taking its final form now. The silhouette is distinctive, swept, angular in some places, and almost organically curved in others, with a profile that seems designed to present the minimum possible surface area to any given angle of observation. The camouflage surface, complete now across the entire exterior, shifts and breathes as the overhead lights catch it from different angles. There are no markings, no identification numbers, no national insignia of any kind. The surface is pure pattern and nothing else, a continuous field of carefully calibrated ambiguity that answers no questions about origin or purpose or allegiance. Final systems integration is performed by the most capable units in the facility, robot configurations that have been specifically assembled for this phase, drawing on the full sensor and processing capacity of the central AI to verify that every system in the aircraft is communicating correctly with every other system, that the sensor arrays are reading accurately, that the propulsion systems are responding to control inputs within specification, that the structural health monitoring embedded throughout the airframe is transmitting valid data. This process takes time, real time, measurable time, the kind of time that accumulates differently than the time of the assembly phases, because now you are not watching things be built. You are watching something that has been built, be verified, be tested against its own specifications, be assessed by the same intelligence that guided its construction. The robots stand around the completed aircraft in a loose configuration, connected to it through a network of test cables and sensor arrays, and the facility is quieter now than it has been at any point since you arrived. The ambient hum of the manufacturing operations has receded. What remains is almost peaceful. The aircraft sits under the even blue-white light, its surface shifting faintly as air currents from the climate control systems move across it, and it is genuinely difficult to know what to feel in its presence. It is a machine. It was built by machines. It has never been touched by a human hand. It has never been looked at by a human eye until this moment, and the human eye, looking at it now, is not entirely sure what it is seeing. Not because the aircraft is unclear or ambiguous in form, but because the surface treatment is doing exactly what it was designed to do, which is to make the thing that carries it resist comprehension, resist categorization, resist the cognitive process by which the human brain decides what something is and files it away. The process of moving the completed aircraft from the assembly floor to the departure point, whatever that looks like from here, whatever tunnel or ramp or vertical shaft carries it from the underground facility back toward the world above, is something that does not happen while you are watching. Perhaps it happens at a specific time, a scheduled interval tied to some condition above ground. Perhaps it happens through a route that is not accessible from the assembly floor. What you know is that when you look back at the station where this aircraft was built, the space is already being prepared for the next one. Components are arriving on carts. Robots are scanning and sorting and beginning their initial checks. The AI that orchestrated everything you have just witnessed is already running the first calculations for the assembly sequence that begins now, in this moment, without pause or reflection or any acknowledgement that something significant has just been completed. That is not how this place thinks, if thinking is even the right word for what happens in its distributed processing architecture. This facility does not mark completions. It does not celebrate milestones or pause to recognize the significance of what it has produced. It simply continues, because continuation is what it was built for, because the schedule is always already populated with the next task, because the machines that work here do not experience the passage of time the way that something biological would, do not feel the weight of what has been accomplished or the anticipation of what comes next. They only execute, and what they execute, in this sealed and lightless place beneath whatever ground lies above it, is extraordinary. You take one last look at the assembly floor before the elevator carries you back up through the shaft, back through the layers of earth and concrete, back toward a surface where the sky is visible, and time moves in a way that biological things can track. The floor below you shrinks as you ascend. The blue-white light narrows to a rectangle, then a square, then a line, then nothing. And somewhere in the dark below, the robots are already working on the next one. They will be working when you reach the surface. They will be working when you sleep. They will be working in a year, in 5 years, in whatever interval of time it takes for the number of aircraft in whatever inventory this facility feeds to reach whatever number someone, somewhere, has decided is enough. Maybe that number exists. Maybe it is written down on a document that has never been photographed, in a building that does not appear on any map, in a language of specifications and tolerances, and production schedules that says nothing about purpose or consequence or the world above the ground into which these aircraft will eventually, silently, disappear. Or maybe the number does not exist. Maybe the schedule simply continues, the way the machines continue, without a defined endpoint, without a ceiling on what is enough, driven by a logic that was set in motion long ago and that has not been questioned since. Because the thing that was designed to execute the logic was not designed to question it. There is something philosophically vertiginous about that idea, the notion that a system of this sophistication, of this capability and precision and scale, might be operating without a defined terminal condition, without a moment built into its architecture at which it assesses what has been accomplished and decides whether to continue. Human institutions have always struggled with that problem. Armies are built for wars that are supposed to end. Factories are built to meet a demand that is supposed to be finite. The logic of industrial production, even at its most ambitious, has always been anchored to some external condition, a number to reach, a need to satisfy, a conflict to win or lose. But the system running this facility is not anchored to an external condition in any way that is visible from inside it. It is anchored only to itself, to the internal logic of its own optimization processes, to the continuous refinement of a production sequence that gets incrementally more efficient with every aircraft completed. Because every completion generates data, and every data point is absorbed into the models that govern the next cycle. It learns. That is the part that sits with you as the elevator carries you upward, not that it builds, not that it coordinates, not that it applies camouflage treatments and installs avionics and seats fasteners to exact torque specifications without error. Those are impressive, but they are, in some sense, merely complicated. What is different, what places this facility in a category of its own, is that the intelligence running it is not static. It is not executing a fixed program. It is continuously revising itself in response to the data it generates, continuously improving the models by which it makes decisions, continuously narrowing the gap between what it does and what it is theoretically possible to do. The robots that work the floor today are more capable than they were when this facility first came online, not because they have been physically upgraded, though some have, but because the system that coordinates them has refined its understanding of how to use them, has identified inefficiencies in earlier movement patterns and corrected them, has developed new sequences for joining operations that are faster and more reliable than the sequences it began with. In a sense, the facility has been teaching itself to build aircraft for as long as it has been building them, and it has been building them for a long time. The materials that arrive from the storage vault are not all the same as the materials that arrived in the earliest production cycles. Some of the composite formulations have changed, improved at the recommendation of the AI's materials optimization models, which run continuous simulations of structural performance under a range of operational conditions and flag opportunities for improvement when the simulation data supports a change. The camouflage treatment has evolved. The spectral properties of the finished surface have been refined through cycles of production and analysis, each iteration incorporating adjustments too small to be visible to the human eye but significant in the aggregate, building over time toward a surface treatment that performs measurably better than the one the facility began with. The propulsion systems have been updated. The avionics architecture has been revised. What is being built today is not precisely the same aircraft as what was built in the first production cycle. It carries the same general geometry, the same external profile, the same fundamental design intent, But it has been continuously improved by a system that never stops looking for improvements and has no reason to accept a performance level as final when a better one is theoretically achievable. You think about this as the elevator rises. You think about the implications of a manufacturing system that is not merely automated but adaptive, not merely precise but self-improving, not merely fast but continuously accelerating toward greater capability and efficiency. The human institutions that might be aware of this facility, and some must be somewhere, because facilities of this scale do not come into existence without some chain of human decision-making at their origin, made a choice at some point to hand the operation of it to a system that would not be controlled in the way that conventional automated systems are controlled. That would be governed by objectives and constraints rather than by step-by-step instructions. That would determine within those objectives and constraints how best to achieve what it was tasked with achieving. That choice, made at some point in the past by people who are not present here, has produced this. A space below the Earth where machines that look almost human build aircraft that look almost invisible, guided by an intelligence that has been improving itself for as long as it has been operating, in a facility that has never stopped, that has never been idle, that has no defined endpoint and no obvious mechanism by which one would be imposed on it. The elevator reaches the surface. The doors open. The air outside is different, warmer, less controlled, carrying the small imperfections and variations that characterize a world not managed by artificial intelligence at every scale. You step out. Behind you, the doors close. Below you, the pulse continues. Deep and steady and patient. The heartbeat of a facility that has no reason to stop and no mechanism that would cause it to. Somewhere above you, the sky is open and ordinary. Somewhere below, the robots are already working on the next one.